In order to better understand inverse trig ratios, we're going to first look at two examples where you need to solve for x. In example number 1, we have x plus 3. We need to get rid of this plus 3 by subtracting 3 from both sides of the equal sign. Plus 3 minus 3 equals 0, and x plus 0 is just x. Drop the equal sign down. 7 minus 3 is 4. In reality, plus 3 and minus 3 are inverses of each other. They undo each other. You're left with just x. In example 2, we have 4 times x. To get rid of 4 times, we're going to divide by 4. 4 divided by 4 is 1. 1 times x is x. Drop the equal sign down. 24 divided by 4 is 6. In reality, 4 times and dividing by 4 are inverse operations. They undo each other. You're left with just x. In example 3, x is inside of the tangent symbol. In reality, x is being tanned, or x is being tangented. In order to solve for x, we need to get rid of this tangent. So how do we get rid of a tangent? Well, we have to use inverse tangent or antitangent. We're going to write the left side of the equation exactly the way it looks, put it in parentheses. And we're going to inverse tangent the left side. This raised to the negative first power means inverse. And if we inverse tangent the left side of the equal sign, we have to inverse tangent the right side. Notice that what's inside of the parentheses is exactly the same on the left side and the right side. The only thing I've added is inverse tangent. Now, much like plus 3 minus 3 are inverses, and 4 times divided by 4 are inverses, tangent inverse and tangent are inverses, and they end up canceling each other out. I'm left with just x. Drop the equal sign down. Tangent inverse of 0.5. So how do I figure out tangent inverse of 0.5? Calculator. Wherever you have tangent on your calculator, you should have a tangent inverse button right next to it. Tangent inverse of 0.5. Rounding to 1 decimal place, I get approximately 26.6. And that's 26.6 degrees. If you remember, this variable after our trig is going to be an angle. Let's apply inverse trig to example number 4. We need to solve triangle ABC. How do we solve triangle ABC? Well, we need to find the missing side of the triangle and both angles. We have angle A and we have angle B. To solve for the missing side, I know 2 sides of the triangle. To figure out the third, Pythagorean theorem. Question mark squared plus 4 squared equals 14 squared. Subtract 16 from both sides. Take the square root of both sides. Question mark equals the square root of 180. But 180 is divisible by a perfect square, and the biggest perfect square that divides 180 is 36. So I'm going to rewrite 180 as 36 times 5, which simplifies down to 6 square roots of 5. So my missing side is 6 square roots of 5. Now I need to solve for my two angles. Let's start with angle A. Across from the right angle is my hypotenuse, and across from angle A is my opposite side. I know all three sides of the triangle, but I want to stick to the two sides that are integer numbers, 4 and 14. Compared to angle A, 4 is opposite, 14 is hypotenuse. So I want to use sine. Sine involves the opposite side and the hypotenuse, and if I use the opposite and the hypotenuse, I stay away from this irrational number and I stick in the integer world. My math is just a little bit easier. So I'm going to take the sine of A equals opposite over hypotenuse. Now I need to solve for A. If you notice, A is being signed. I need to inverse sine both sides of my equation. Sine inverse and sine undo each other. I'm left with A equals the sine inverse of 4 over 14, which is approximately 16.6. And A is an angle, so it's going to be 16.6 degrees. Now let's solve for angle B. I could use any of the three trig ratios, but I want to stick to using 4 and 14 since they are both integers. Looking at angle B, 4 is adjacent to angle B. The trig ratio that I want to use is cosine. The cosine of B is going to equal adjacent over hypotenuse. Now this looks a lot like my first equation, but I have cosine in here. To solve for B, I need to inverse cosine both sides of the equation. Cosine inverse, cosine undo each other. I'm left with B equals the cosine inverse of 4 over 14, which I can approximate using my calculator. Rounding to one decimal place, 73.4 degrees. Now I can check those answers. If you look, my two acute angles in a right triangle have to be complementary. Yep, they do add to 90 degrees. So I know that these two are the correct answers.